Hey y'all, so today we're going to be talking a little bit about symmetry in these quadratics that we've been talking about. So for this first little bit, it says Dean's little sister Dina is studying symmetry in her math class and asked him to help her draw the lines of symmetry on figures A, B, and C. Sketch the lines at the right and describe a line of symmetry in your own words below. So if we're looking at A, I know that if we cut it like this, it will be symmetric on both sides. All right. And what about B right here? Well, if we go down, that would cut it in half like that. We could also go horizontally. But since it's a square, we can also go diagonally. So that one has 4 lines of symmetry. 1, 2, 3, and 4. Now this shape over here, well, we can't go vertical anywhere, but we can go horizontal. So there's let it focus there for a second. There it goes. All right, but then now we move to our quadratics, right? So we kind of talked about this a little bit yesterday, or even Tuesday, but this vertex right here, we talked about how that is going to split this quadratic into 2 equal parts if we draw a line straight through it. Well, same thing here. Find the vertex, and we're going to go straight down through it. Now, again, Dina notices Dean's homework and mentions that the parabolas have a line of symmetry, and so we just sketched those just now. So D and E, it would just be that vertical line splitting it in half. So again, similar to a line of symmetry, parabolas representing quadratic functions have what we call an axis of symmetry. And that equation is always going to be x equals. So it's always going to be x equals something. Okay, so let's talk about that here in just a second, and then we'll do a couple of examples to hopefully help you kind of see what we're talking about here. So let me go down a little bit. So axis of symmetry. So the axis of symmetry is the vertical line that passes through the vertex of a parabola. Okay, so if we remember from yesterday or even Tuesday, this was called our vertex, which means this dashed line right here is the axis of symmetry. Boom. So each point on the parabola will have a point with the same y value in the same distance from the axis of symmetry. Think of these points as reflected image points. Right, so for example, if we were to pick this point right here, right, it is 1, 2, 3, I might have miscounted, 1, 2, 3, 4 away. So when we go the other way, 1, 2, 3, 4, we end up right back on the same part of the graph. So just like we talked about on Tuesday, a quadratic, regardless if it's shaped like this one up here or this one down here, is going to have an axis of symmetry or a line that cuts through the vertex, splitting it in half. Okay, so if you want, you can pause this and try to do the examples below, but if not, just keep going, and I'm going to go through some of these examples here at the bottom. Okay, so let's take a look. So for each parabola below, identify the vertex, then draw a dashed line to represent the axis of symmetry and write the equation of the line. So first thing is always to find the vertex. So here, my vertex would be right there. And again, for a vertex, just like we talked about, we want to have an x and a y value. It is a point, right? It's a point on the graph. So again, x and then y. So if I start at the origin, I have to go left 1, 2. So I know my x value is -2. And then we have to go down 1, 2, 3, 4, 5, 6, 7. So we're at -7. So -2, -7 is our vertex. So then from there, we are going to sketch our axis of symmetry, which is going to be a vertical line that cuts right through the vertex, just like that. Okay, now the equation is always going to be x equals, x being because a vertical line is an x equals equation, y equals would be a horizontal line. Well, x equals, well, what is our x value of our vertex, right? Well, what x value is this cutting through? Well, it's cutting through -2, which is also the x value of our vertex. So that's the pattern that you're going to see happening as we do a couple of these. Okay, so looking at number 2, same thing. Find the vertex first. That's that point right there, which is at, well, 0.51, 1.5, comma, and then I have to go up 0.5, 1, 0.52, 0.53, so 1.53. Sorry, the lights just cut off on me. There you go. Now our equation, again, just like we were here, if we were to sketch a line that goes through the vertex vertically, it would look something like that. And our equation would be x equals 1.5, again, which is the x value of our vertex. Okay, so let's flip it to the back, and we think we have a couple more examples, or actually we don't. We have kind of a summary of how we can find the axis of symmetry if we did not happen to have a graph, right? So when a function is in standard form, and if you don't remember what that is, that was ax squared plus bx plus c. Remember, a tells us whether it's opening up or down, whether we're going to have a max or a min. The b is what's in front of the x term, and the c is the constant at the very end. So we can use a formula to find the axis of symmetry as well as the x value of the vertex. And that formula is this right here. X equals -b over 2a. Now, when I say -b, I want you to think of that as the opposite of b, right? And it also says -b over 2a is the x coordinate of the vertex, which makes sense, right? Because if I flip it back over for a second, our x value of our vertex was the value that we needed for our axis of symmetry. So this is going to be our equation that we're going to try here for this one right below. And then we'll do a couple little things at the bottom, and then we'll wrap up. So it says the graph of f of x equals x squared plus 8x plus 13 is shown on the right. So that's this graph here. Complete A through D and check your answers with the graph of the function. So we're going to fill in our A, B, and C. Now remember, the A is in front of the x squared. So if I'm looking in front of the x squared, well, that has an invisible 1. So our A value is 1. Our B value here in front of the x term, which is 8, you got to be careful. If that was minus 8x, it'd be a -8. But this is positive 8. And our C value is 13. Okay, but now for the axis of symmetry, we only need the B and the A, right? The C value really only tells us the y-intercept. If this kept going up, it would cross at 13. But for what we're about to do, we really only need the A and the B. So let's write the equation of the axis of symmetry. So it would be x equals -b. So let's think of that as the opposite of b. So if we have a positive 8, we're going to put in a -8. Now, if we had a -8, this would be a positive 8 because positive 8 is opposite of -8. But then in the bottom, we're going to have 2 times a. So 2 times my a of 1. Well, 2 times 1 is just 2. So we get -8 divided by 2. And well, -8 divided by 2 is -1. 4. So the axis of symmetry is x equals negative 4. Well, let's check that on the graph, right? We find right here negative 4, and if we sketch a graph or a line that cuts through that, I don't know about you, but that looks like it would indeed be the axis of symmetry. So then it asks, if negative b over 2a is the x value of the vertex, how can this be used to find the y value of the vertex? Well, we just found that this was the x value. All we have to do is take this x value, plug it in for x, and we can get our y value. So that's what we're going to do. We're going to do x squared, but we're going to plug in negative 4 squared plus 8 times negative 4 plus 13. Okay, now negative 4 times negative 4, which is negative 4 squared, is positive 16. 8 times negative 4 is negative 32 plus 13. Well, 16 minus 32 is negative 16. Negative 16 plus 13 is negative 3, which means my vertex is going to be negative 4, negative 3. Which again, if we check on the graph, negative 4 down 1, 2, 3. So if you did not have a graph, you can still find all this information by doing just a little bit of algebra. Okay, so for each of these ones down here, we're going to find the negative b over 2a, the axis of symmetry, and then also the vertex. So let's look at 4 real quick. So 4, again, the easiest thing is to identify your a and your b. We don't, again, it's good to identify your c, but we don't really need it too much here. Okay, so our b is, well, let's go ahead and label that. A is 2. B is negative 20. Okay, so when we do negative b over 2a, well, we have a negative 20, so the opposite of negative 20 is positive 20 over 2 times our a, which is 2. So we have 20 over 2 times 2, which is 4. And 20 divided by 4 is 5. So negative b over 2a is 5, which means our axis of symmetry is x equals 5, which also means our vertex is 5, comma, something. So we have to take this 5 and plug it back in and see what we would get out, right? And again, for this stuff, I don't mind if you guys want to use a calculator, which I'm going to do. So I'm going to do 2 times 5 squared minus 20 times 5 plus 51, and we get 1. So that means that our vertex is 5, 1. 5, 1. Okay, and if you graph this function in your Desmos, you would see that it should be at 5, 1. Okay, I'm going to try to go through the rest of these pretty quickly. You can just pause whenever you need to. So this next one, negative b over 2a, my a is 1, my b is negative 8. Sorry, my a is negative 1. I got to be careful. It's a negative x squared. So negative 1 and negative 8. So the opposite of negative 8 is positive 8, divided by 2 times my a, which is negative 1. So 8 divided by 2 times negative 1 is negative 2. 8 divided by negative 2 is negative 4. So negative 4 is our negative b over 2a, which means our axis of symmetry is x equals negative 4, and our vertex is negative 4, comma, something. Right, now, when you're plugging this in, you need to make sure that you keep your stuff in parentheses, right? So I'm going to swap over to Desmos for this one. So we have negative x squared, so negative 4 squared, right? So when I'm plugging it in, it's still that minus out in front. Then we plug in -4, and then we square it. Minus 8 times -4 minus 8, I believe. Yep, minus 8. And that all gives me positive 8, which means my vertex is at -4, 8. Okay. Now, be careful here because they switched up the order, right? The a is in front of the x squared, so the a here is 4. And the b, well, the b in this case happens to also be 4. So we got negative b, so -4 over 2 times a. So -4 over 8, which is equal to -1/2. So -1/2, which means the axis of symmetry is x equals -1/2, and our vertex is at -1/2, comma, something. Right, and then again from there, we just have to plug that into our calculator. So 4 times -1/2 plus 4 times -1/2 squared, which is -1. Okay. Now, to answer this question, it asked, Sam is going to graph the function. In which quadrant will the vertex lie? Well, if we can figure out what the vertex is, we know which quadrant it's going to lie in. Meaning, is it going to be in the first, second, third, or fourth quadrant? Right? So here, let's do the -b over 2a. So the a is 3, and the b is 18. So -18 over 2 times 3, which is -18 over 6, which is equal to -3. Right? So we know our vertex is -3 something. So if we're thinking of the quadrant, it's either got to be in this one or in this one because we're in the negatives, right? So to figure out exactly where it's at, we're going to have to find that y value by taking this -3 and plugging it back in. So that would be 3 times -3 squared plus 18 times -3 plus 24. And again, that's something that you could plug into the calculator like we were doing before. So 3 times -3 squared plus 18 times -3 plus 24, which also gives me -3. So -3 would be your vertex, which means in terms of the quadrant, that would be here, here, so somewhere down in here. So that'd be the 1, 2, third quadrant. Oh, I don't know if you can see that. Third quadrant. Okay. Now the last one is a little error analysis. So it says Jerome's work to find the axis of symmetry equation for y equals 1 plus 8x minus 2x squared is shown below. Describe his mistake and find the correct equation. Sorry, the lights went out again. So let's see what he did. So he started with the correct formula, but then he put -8. So he says the b is -8. So let's find our a and our b real quick. So our a is -2. Our b is 8. Okay, so far that -8, that looks fine. 2 times 1. But our a is supposed to be -2. He mistook this for being the a value. So what he should have done is he should have had -8 over 2 times -2 instead of 1. Which would then give us -8 over -4. A negative divided by a negative is going to be a positive, so the actual answer should be x equals +2. Okay, feel free to watch this video back as many times as you want and use it to help you answer some of those questions on the worksheet that you will take a look at here in just a moment. So tomorrow will be a little different, but again, it'll be another video, so just make sure you watch it and complete the notes just like you did for this one. and I will see you guys back on Monday.